Imagine waking up tomorrow and the internet is gone. No Google, no email, no online banking, no YouTube. Suddenly the world feels very 1980. Now here's the interesting thing. The internet was never originally meant to entertain us or connect friends on social media. It was born from fear. Fear of war. Fear of losing communication. Fear that one attack could silence an entire country. And the people who built the internet were not tech billionaires. They were mathematicians, engineers, government researchers, and a few very stubborn dreamers who believed something radical. Computers should talk to each other. This is the incredible story of how that idea slowly turned into the modern internet. To understand the internet, we first have to travel back to a time when computers were lonely machines. In the 1950s and early 1960s, computers were massive devices that filled entire rooms. You didn't log in from home. You physically went to the building where the computer lived. People fed instructions using punch cards, waited hours, and collected printed results later. Sharing data between computers was almost impossible. The only large communication network at the time was the telephone system, but telephone networks used something called circuit switching. Think of it as having your own exclusive lane, reserved just for you. When you make a phone call, the system creates a dedicated connection between two telephones. That connection stays open for the entire conversation. This works great for voice calls, but it is terrible for computers. Why? Because computers send data in short bursts. Most of the time, the connection would sit there doing nothing. Worse still, if part of the network was destroyed, the whole connection collapsed. And in the 1960s, people were very worried about exactly that scenario, because the world was deep inside something called the Cold War. After World War II, two superpowers dominated the planet, the United States and the Soviet Union. Both had nuclear weapons. Both distrusted each other deeply, and both were racing to build better technology. In 1957, the Soviet Union shocked the world by launching Sputnik, the first artificial satellite. For Americans, this was terrifying. If the Soviets could launch satellites, they could also launch nuclear missiles. The US government responded by creating a new research agency in 1958, called the Defense Advanced Research Projects Agency, or DARPA. DARPA had one mission: fund bold scientific ideas that might give the United States a technological edge. DARPA didn't build weapons directly. Instead, it funded scientists and universities to experiment with futuristic ideas. One of those ideas would eventually change the world: networking computers. Around the early 1960s, a researcher named Paul Baran at the RAND Corporation began thinking about a terrifying problem. What happens if nuclear war destroys communication centers? Traditional telephone networks relied on central hubs. Destroy the hub, and the network dies. Baran imagined a different kind of network, a distributed network. Instead of one central hub, many smaller nodes connected together. Messages would be broken into small pieces called packets. Each packet could travel independently through the network. If one path was destroyed, the packets would simply find another route. Meanwhile, across the Atlantic in Britain, scientist Donald Davies independently developed the same concept. He even coined the term packet switch. This idea solved two major problems. First, networks became far more efficient because connections weren't reserved for long periods. Second, networks became resilient because messages could reroute around damage. This concept became the foundation of modern networking, but theories needed proof, and DARPA decided to test it. DARPA funded a research network connecting several universities. This experimental network was called ARPANET. The goal was simple: let researchers share computing resources and test packet switching networks. In 1969, something historic happened. A student programmer at UCLA tried to log into a computer at Stanford Research Institute through ARPANET. He typed L, then O. The system crashed before he could finish typing login. Then he tried again, starting all over with L. You could say the first three letters, LOL, became the first message ever sent across what would become the internet. Funny, right? ARPANET slowly expanded as more universities joined. Researchers started using the network to share files, run programs remotely, and exchange information. But there was a growing problem. every network spoke a different language. Could we possibly connect all networks if they all spoke different languages? For computers to communicate, they need rules. Those rules are called protocols. A protocol defines how a message starts, how data is divided, how errors are detected, and how devices confirm messages arrive. Early networks used different protocols. Some used radio signals, others used satellite links, others used telephone cables. Even the signals themselves had to be converted. This conversion process is called modulation. A modem, short for modulator-demodulator, turns digital computer signals into sounds that can travel across telephone lines. Think of it as translating computer language into phone language. The problem was clear. If each network spoke a different language, how could they ever connect together? Two engineers began working on that problem: Bob Kahn and Vint Cerf. Kahn and Cerf proposed a radical idea. Instead of forcing every network to be identical, create a universal language that allows different networks to communicate. Their system was called TCP-IP. The idea was simple but powerful. IP, the Internet Protocol, would handle addressing and routing packets across networks. TCP, the Transmission Control Protocol, would ensure the packets arrived safely and in the correct order. Together, these protocols allowed many independent networks to behave like one giant network. In 1983, ARPANET officially switched to TCP/IP. Many historians consider this moment the true birth of the internet. But networking was about to become personal because someone created the first killer app. In 1971, engineer Ray Tomlinson was experimenting with programs on ARPANET. He modified an existing messaging system so that messages could be sent between computers. But he needed a way to separate the username from the machine name. So he chose a symbol rarely used on keyboards, the @ sign. User at computer, user at computer. He sent the first network email to himself. He later said he couldn't even remember what the message said, but it didn't matter. Email spread across ARPANET almost instantly, and people loved it. For the first time, computers were not just machines for calculations. They became tools for communication. As the network grew, new challenges appeared. Someone had to keep track of computer names and addresses. A researcher named Elizabeth Feinler maintained a file called aoss.txt, which listed every machine on ARPANET. But the network grew too big for one list, so scientists invented the Domain Name System, or DNS, created by Paul Macapetris. DNS acts like the internet's phone book. It converts human-friendly names like google.com into numeric IP addresses. By the late 1980s, the internet technically already existed. Universities were connected, researchers could send email, files could be transferred. But there was one big problem. The internet was still very difficult to use. Most interactions happened through command lines. You had to remember strange commands just to retrieve a document. If you were not a computer scientist, the internet felt like a locked library where only experts knew how to find the books. And this frustration was exactly what led to the next breakthrough. At the European Physics Laboratory CERN, scientists from different countries worked on huge experiments together. One of the engineers there was Tim Lee, and he had a very annoying problem. Researchers were constantly creating documents, data files, experiment notes, and reports, but they were stored on different computers using different systems. Finding information became a nightmare. You might need to check several computers just to read one research paper. Berners-Lee later described it as a kind of information chaos. So in 1989, he proposed a simple but powerful idea. What if documents could be linked together? Instead of searching computer by computer, you could click a link and jump instantly to another document anywhere on the network. To make that possible, he invented three things. HTML, a simple language for creating web pages, HTTP, a protocol for requesting and transferring pages, and URLs, addresses that identify documents on the network. Together, these created something new: the World Wide Web. At first, it was just a small system used by physicists, but once the idea spread, people realized something incredible. The internet could now be visual, clickable, and easy to explore. No complicated commands, just links. Soon, browsers appeared. One of the earliest popular ones was NCSA Mosaic, which allowed users to see images and text on the same page. Later, browsers like Netscape Navigator made web surfing fast and exciting. Businesses noticed immediately. Companies realized something important. If they could connect ordinary households to the internet, they could build an entire industry. These companies became known as Internet Service Providers, or ISPs. Early services like CompuServe, AOL, and Prodigy Communications began offering dial-up internet connections. You connected your computer to a telephone line using a modem, and suddenly your home computer was connected to the global network. People were fascinated. In the mid-1990s, millions of households began joining the internet for the first time. Email became common. Chat rooms appeared. Online forums exploded. The internet was no longer just for scientists. It was becoming part of everyday life. But one problem remained. You still had to stay physically connected by a cable, Wi-Fi. The idea was absolutely revolutionary for the internet. Instead of connecting your computer with a cable, your device could send radio signals to a nearby router. That router connected to the internet. Networking engineers in the 1990s began developing wireless networking standards under the Institute of Electrical and Electronic Engineers. Suddenly, the internet was no longer tied to a desk. You could use it in cafes, airports, homes, universities, and even parks. Eventually, smartphones joined the network too, and that's when the internet truly became mobile. By the late 1990s, investors poured billions of dollars into internet companies. This era came to be known as the dot-com boom. The internet stopped being a technology experiment and became the core of the modern world, powering communication, banking, entertainment, education, and more. The network had finally escaped the laboratory, and it wasn't going back. Resolution: the internet becomes human. The internet was not invented by one person. It was built by hundreds of researchers solving small problems: packet switching, protocols, email, DNS, the web. Each piece was like part of a puzzle, and together they created the largest communication system humanity has ever built. Every message you send today travels across that same foundation. So the next time your Wi-Fi stops working and you feel like the world is ending, remember the incredible journey behind that tiny signal. And in a strange way, every time you send a message online, you're continuing the story they started just by being part of the internet.